Welcome to our video. We're going to be going over Unit 1, Lesson 6 in your Unit 1-2 workbook for Math 3. So make sure you have your workbook out, turn to page 66, and we're going to get started. This lesson is going to be focusing on absolute value equations and inequalities, and you can see the North Carolina standards that are covered down here below. Without further ado, let's get going. In this video, our learning targets are going to be to understand why absolute values can have two solutions, how to solve those absolute value equations graphically and algebraically, and how to solve inequalities graphically and algebraically. And there's going to be a bridge, a warm-up, and some activities down below, including a cool down and a lesson debrief at the end. Now, when you're in class, make sure that you're completing the activities together with your teacher. But anything that you missed or maybe needed some reinforcement, go ahead and check out the stuff in this video to help you along. But it is expected in your classes that you're completing the activities with your teacher and classmates together. Let's get started. Okay, so for the bridge, which is going to be found on page 66, what you're going to want to do on these problems is use your memory about what you remember how to solve for equations and inequalities and take 10 minutes individually. Set yourself a timer and see if you can try all these, and then we'll go over these questions at the end of those 10 minutes. I'm going to pause the video. What I want you guys to do is click pause on this video, try these on your own, and then come back and I'll start going over them. Okay, for the first question, you have the equation negative 3x equals 12. And for this one, you do want to divide both sides by negative 3. And so when you solve that out, you're going to get 12 divided by negative 3, and that's going to end up being negative 4. For question 2, on this equation, we do want to add 7 to both sides before we divide. So we'll do plus 7 to both sides, so getting rid of that minus 7. 14 plus 7 is going to end up being 21. So your equation ends up becoming 2x equals 21. Now, when you divide those numbers, you're going to get a decimal or a fraction, depending on your method of writing your answer. But 21 divided by 2 is going to be about 10.5 or about 10.5. So I'll write 10.5 for our final answer for that one. So negative 4 and 10.5. Number 3 looks a lot like number 1, doesn't it? The difference here is that you have an inequality symbol. This is a greater than. So you do want to divide by negative 3 on both sides, and you're going to get negative 4. But what happens is you can't just say x is greater than negative 4. What's going to end up happening on these divisions, when you divide by a negative, the sign of the inequality is going to change direction. So instead of saying x is greater than negative 4, we're going to say x is less than negative 4. Question 4. Question 4 is number 2, but with an inequality. This is 2x minus 7 is less than or equal to 14. We're going to solve it in the same way we did number 2. So we're going to add 7 to both sides and get 21. And you'll have 2x is less than or equal to 21. We're still going to divide both sides by 2 and get 10.5. Now, because that is a positive, there is no need to change the direction of the inequality. So we're going to leave that as x is less than or equal to 10.5. So we only change it when it's a negative. We flip the direction, okay? So a little bit of a memory jog from solving inequalities back from a previous time. All right, go ahead and go on to the warm-up down below on page 66. The purpose of this warm-up is to get you thinking about what possible answers could be the value of x when you have an absolute value. Remember, those vertical bars mean absolute value, and what it ends up meaning is the absolute distance from 0 on a number line. So when you talk about the absolute value equals 9, can you think of some numbers that will make that equation true? When you talk about number 2, the absolute value of x plus 2 equals 9, think of some numbers that'll make it true. What I want you guys to do is click pause again and try to think of those numbers without using other means like a calculator or solving equations. Just see if you can think of those numbers by in your head, and then we can go over them. So let's start with number 1. The absolute value of x is equal to 9. Well, let's think about what number that would make true. If I put inside the absolute value bar, let's say 9, well, that's of course true. The absolute value of 9 is 9. But what other number has an absolute value that's equal to 9? That's right, negative 9. So there's actually 2 answers to that. X is going to equal positive and negative 9. You could say plus or minus 9. I'm just going to say 9 and negative 9. Number 2 is got a plus 2 added inside the absolute value bars, but that doesn't change the thinking that goes along here. What ends up happening is you want to be able to come up with something that makes all of that equal to negative 9 or positive 9. So let's just start with positive, right? We know that we want that to be the absolute value of something is equal to 9. So what makes x plus 2 a number that when I take the absolute value, I get 9? Well, let's think about it. What plus 2 is going to give you 9? That's right. X should be 7. Because if I plug in 7 there, 7 plus 2 is 9. The absolute value of 9 is also 9. So 7 is going to be one of your answers. Can you think of another number that would work? What if we do negative 11? What's negative 11 plus 2? Negative 9. What is the absolute value of negative 9? 9. So negative 11 would also be a valid answer. So negative 11 and 7. What about the absolute value of 3x equals 9? Well, similar situation, right? We want 3 times a number to give you 9 or negative 9. So if I think about 3x and me wanting this number to be 9 or negative 9, well, then x would have to be some number that gets you 9, right? I want that to be 9 or negative 9. So 9 divided by 3 is going to give you 3. So x could be 3. And if I plugged in 3 here, 3 times 3 is 9. But what other number works? That's right, negative 3. Because if I do 3x equals negative 9, and I divide by 3, I'm going to get negative 3. So there's 2 distinct answers for that as well, positive 3 and negative 3. Question 4. I want the absolute value of x to give me a negative 9. Now, the rules of absolute value state that if I plug in a number, am I able to get a negative value once I apply the absolute value to that number? And as hard as you might try, you can think about it. If I plug in negative 9 in there, that's not going to give me negative 9, is it? It's going to give me 9. If I plug in 9, that's going to still give me 9. So there is no number that I could plug in for x that when I apply the absolute value, I get a negative. So this would have no solution. No solution. You cannot get a negative in this problem. Great, I hope that got you thinking of some values that could help you solve equations. Now we are gonna use different techniques to solve them, so we don't always have to think of them in our head. Go ahead and flip over to page 67, and we're gonna go over activity 1. Activity 1, page 67. We're trying to figure out how to mathematically solve these using some algebraic techniques. So the question is, Andre likes thinking of absolute value functions as piecewise functions, like he did in activity 2 of the previous lesson. So you can look back on lesson 5 to kind of see how that was done. He thinks that to solve the equation from the warm-up, absolute value of x plus 2 is equal to 9, algebraically, he could use 2 equations. His thinking is if he does x plus 2 equals 9, and he also does the negative x plus 2. So he makes the stuff inside the absolute value negative, also equal to 9. And he got 2 answers, 7 and negative 11. Well, go back and check your warm-up and look at the second question on the warm-up. Did he get those answers correct? and this is what we got when you go over the video with me. I got negative 11 and 7. He got negative 11 and 7 as well. So I guess the question, this is kind of open-ended, do you think Andre's method is going to work for all absolute value equations? So think about that, and let's look at the next question. Okay, what we want to do here is we want to use Andre's method to solve the following equations, substitute your answers back into the original equation to verify they are correct. So this is going to be some work, and you're going to want to use all the space that you have in this page. Likely on this page, you'll need some extra space, so if you need to use some extra paper, you can. But go ahead and pause the video, see if you can come up with your solutions using that technique from the first part of this activity. All right, this is how I'm going to work them out. Please follow along if you're struggling with the technique here. So first of all, using Andre's technique, what we'll do is we'll say 2x minus 1 equals 11. And then we'll say negative, parentheses, 2x minus 1, close parentheses, equals 11. So we'll set up both of our equations like this. Now try to solve that if you haven't done so. Okay, A's worked out. Let's go through each of those setups and solve them. So for the one without the negative out front, that's a little bit easier. We would want to add 1 to both sides to get rid of that minus 1. Then we're going to get that equal to 12. We'll divide by 2 in front of the x. 12 divided by 2, that's 6. And so one of your answers is 6. If you substitute that back in and do the absolute value of 2 times 6 minus 1, you'll get 12 minus 1 in the absolute value. Absolute value of 12 minus 1 is absolute value of 11. That checks out. Over here, you have this negative out front. So if you're solving it this way, you're going to want to distribute that negative. Notice that this becomes a positive value because that negative and negative make a positive. Then we're going to still subtract the 1 to get 10. Divide by the negative 2, you'll get negative 5. Is negative 5 an answer? Plugging that back in, you'll get 2 times negative 5, which is negative 10. Negative 10 minus 1, that's negative 11. Absolute value of negative 11 is 11. So we're going to go through each of those equations that you see on activity 2 in that same manner. Again, pause it, try them on your own if you haven't done so. Let's work it out. So we want to set up our two equations, x minus 12 equals 2, negative parentheses x minus 12 equals 2. As we're going through it, this one on the left side, you're just going to add 12 and you'll get 14. You can plug it back in if you'd like. The absolute value of 14 minus 12 is the absolute value of 2. So that's going to give you the right answer. Over here, if you distribute that negative, you're going to end up getting negative x plus 12. Subtracting the 12 from both sides, you'll get negative 10. Now you have to get rid of that negative x. So, and you can divide by negative 1. That's going to give you positive 10. And if you go back and plug that in, the absolute value positive 10 minus 12 was the absolute value negative 2, which is also 2. So that checks out. We'll go through the other two a little bit faster. Again, keep pausing it so you can check your work. All right, this one's worked out for you. I kind of typed out the solutions here. I'll go through a couple things that I did. On this one, I did subtract 5 from both sides. So 12 minus 5 is going to be 7. Now, when you divide it by 3, you're going to end up getting a decimal or a fraction. So I left it as a fraction, 7 divided by 3. I did not show the plugging in method because I think by this point, you're probably realizing, yeah, that's going to work. And over here, I distributed the negative into there. So I'm going to get negative 3x minus 5. Again, I didn't show the step here, but you will want to add 5 to both sides because that's minus 5. And that's going to give you 17. And then 17 divided by negative 3 is going to be negative 17 over 3. So you'll have two solutions, negative 17 over 3 and 7 over 3. And by now, you're probably going to realize these absolute value equations, they can have more than one solution. Again, that last one we'll show worked out. All right, you may have struggled with this one, and simply put, this one doesn't have a solution. When you use that same technique and you try to solve for both sides, what's going to end up happening is you're going to get this answer negative 4 and negative 2. But if you substitute those back in, negative 4 plus 3 is negative 1. Absolute value of negative 1 is 1. But the equation has negative 1 out here, not 1. So that's not true. Same over here. When you plug in negative 2 here, negative 2 plus 3 is 1. Absolute value of 1 is 1, not negative 1. So there's kind of a glitch in the matrix, okay? When we have it equal to negative 1, that's just going to be no solution. Anytime you have a negative number out here, it doesn't matter what that number is, negative 10, negative 1. Once you isolate that absolute value and it's equal to negative 1, there's going to be no solution to that problem, okay? So I can't stress that enough. Double check what you're setting it equal to begin with so you don't make that mistake of going through all of that here with me. All right, you can flip the page to page 68. We'll go over the Are You Ready for More? Okay, for the Are You Ready for More? Just to get you thinking about the graphing activities we're going to be doing in the next couple examples. So for number 1, it says, use Desmos to graph the equation y equals the absolute value of 2x minus 1. Now, in your previous lesson, you should learn how to graph absolute value graphs. So if you need help with that, please refer back to that. Also graph y equals 11. The question says, on the next line, graph the line equation y equals 11. Sorry, I already did that. What is the solutions to this system of equations? Notice that there's going to be 2. If you click on those coordinates, you'll have negative 5 and 6. Both give you solutions to that equation. So you can solve an equation graphically as well. So negative 5 and 6. Question 2. Graph the equations y equals 0 and y equals the absolute value 2x minus 1. And I've already done the absolute value 2x minus 1. So they want to know what's the solution. If you zoom in, you will see 1 point, and that is going to be 0.5. 0.5. Moving on to question 3. Graph the equations y equals the absolute value of x plus 3 and y equals negative 1. What is the solution to the system of equations? Well, these guys do not cross, so that's going to be no solution. So for question 4, it does ask, what does a system of equations with an absolute value function and a linear function look like when it has 1, 2, or 3 solutions? So I have a few picture representations to show you. Basically 2 solutions. They're going to cross 2 times. 1 solutions, they'll cross once. Now you'll notice that in our example above, it ended up crossing at the vertex, but it can cross like that. It can be like a very steep slope versus the absolute value slope. And no solution is not going to cross at all. All right, we are ready for activity 2. In this activity, you want to explain the steps that are shown using Andre's method for the absolute value of x plus 6 minus 9 equals 18. Go ahead and pause the video, see if you can write down your explanations for each step, and then I'll show you what I have to say. All right, here are my steps for question number 1 and activity 2. For step A, I just said rewrote as positive and negative, depending on which equation you're writing. Step B, I said added 9 to both sides. Step C, for the left side, I would say subtracted 6. And then for the right side, I said distribute the negative. And notice that that one's already done. For step D, I said add 9 to both sides. I should have said 6, excuse me. Add 6 to both sides. And the last one I said divided by negative 1 to get you negative 33. In question 2, you're going to want to try these ones on your own. So pause the video again, and you can check my answers as you unpause. All right, check my work for 2A. On the left side, I just simply rewrote it. Parentheses x minus 4 plus 5 equals 12. Got rid of the parentheses, 5 and negative 4 add to 1, and then subtracted the 1. On the right side, I used the negative around what was the absolute value, but I changed them into parentheses, distributed the negative, and then I do the 9 there for the 4 plus 5, subtract the 9 from 12 to get 3, but since the x is negative, divide by negative 1 to get x is negative 3. And you can plug those back in to double check that those work. Try letter B. All right, here's my work for letter B. Same scenario, a little bit more challenging for the equations, but the work is still the same. You're going to replace the absolute values with parentheses, and then one of them you're going to have a negative outside. Now in this one here, since there was a 5, what I did was I just put the negative with the 5. Follow my steps and just pause it along the way if you have any questions, but you can see I distributed that negative 5 and just solve it using regular algebraic techniques. Again, you can plug your answers back in to double check your work at the end. All right, see if you can figure out letter C. Before you go racking your brain trying to figure out that same technique, always, make yourself problem be a little simpler, okay? And this problem right here, you might want to consider getting rid of everything around the absolute value before you actually solve the equation. Maybe subtract that 4 from both sides first. Well, 10 minus 4 is 6. Okay, I got that. Well, then what, Mr. Weiser? Well, then we rewrite it. So we'd say negative 2, absolute value, x minus 1, equals 6. Now, can't distribute a negative into an absolute value. What you can do is you can divide both sides by a negative. So if I say divided by, let me change that color there, negative 2. Cross that out, you're going to get the absolute value of x minus 1, drum roll please, is equal to negative 3. Mr. W, we just learned that we can't have an absolute value equal negative. That is correct. This is not going to work. No solution. So there's no number you can plug in here. Take the absolute value of that, if you subtract 1, multiply negative 2, add 4, and you're going to get positive 10. This has no solution. So don't go through that whole process of solving if the absolute value bars isolated stuff inside equals a negative on the other side of the equation. It won't work. Watch. If I were to go through that graphing exercise that we did on the Are You Ready for More, you'll realize that I can say y equals negative 2, absolute value x minus 1, close absolute value plus 4, and say y equals 10. You can notice there is no point of intersection. They're not going to cross. So there wouldn't be no solution graphically, so you can't make a solution algebraically, magically out of nowhere, if you don't see where they cross. All right, let's go to the Are You Ready for More on page 70. Are you ready for more? Tyler thinks they can solve the equation 3 absolute value x plus 6 minus 9 equals 18 by taking the opposite as shown below. Why didn't Tyler's method work? So if you go through and you look at these two setups for the equations, actually only one of those is done correctly. So you can figure out which one's done right and make some modifications so how we could change it. Pause, try it on your own. All right, you figure it out? So it turns out that one's correct. If I plug in 3 here, we're good, right? Absolute value, 3 plus 6, that's 9. 3 times 9 is 27. 27 minus 9 is 18. No problems with the way this one was done. Over here, though, that negative 18 should not have been there. If we're following the same procedures that we did before, we don't want to do that, okay? We want to fix that because we want to make this negative. All right, this is where the negative should be. Okay, so we're going to fix all this. I'm going to redo it. It's going to be negative 3 absolute parentheses x plus 6 minus 9 equals 18. Now we're going to add the 9 to both sides. Actually, let me distribute the negative first. That'll probably be more consistent with how you learned it in the previous part of the video. So negative 3 minus 18 minus 9 equals 18. If I combine negative 18 and negative 9, that's going to be negative 27. And if I add 27 to 18, 27 and 18, what's that going to give us? Let's see, 8 plus 7, 15. 55, or sorry, 45. Where's my brain going? 45. So negative 3x equals 45. And then divide both sides by negative 3, and you should get negative 15. Let's see if that works. Does negative 15 work? Let's go back and plug it in. 3 absolute value, negative 15 plus 6. Yeah, what's negative 15 plus 6? That's right, it's negative 9. So that should work, right? 3 times the absolute value of -9 is 3 times 9. 27 minus 9 is 18. So both of those work. Now we have our consistent method of doing this. Go ahead and move on to activity 3, spicy hot inequalities. For activity 3, the scenario is spicy cheese crunchers are advertised. They can't just say Cheez-Its, right? They got to say spicy cheese crunchers, advertised to weigh 240 grams each in a randomly chosen batch of 200 bags. All bags have an absolute error that is 3 grams or less. In other words, it's 3 above or below that 240. This can be represented with the inequality. Absolute value of x minus 240 is less than or equal to 3. Andre is told to solve this inequality, and he's wondering if his method works for solving absolute value inequalities. So let's solve using Andre's method. Here's the part on the left. Add 240 to both sides. Now, when you add a number to both sides, that doesn't change any direction the inequality should look like. So it's really x is less than or equal to 3. 243. What about over here? Well, we're going to distribute that negative, right? So negative x plus 240 is less than or equal to 3. And we're going to subtract that 240 and get negative 237. Then we're going to divide by -1 because we don't want this negative x hanging out. Now what happens is this is going to reverse. This is going to go, whoop, greater than or equal to negative 237. Because remember, when you divide by negative, inequality symbol reverses order. Now we have 2 separate inequalities, and we've got to put them together. Well, how do we do that? Think of a number line. All right, I have 243. I want to represent x is less than or equal to 243. So I could shade to the left of 243. But then if you go over here, it says x is greater than 237. So if I continue that, well, that works for this part. But if I do x is greater than 237, then I'm going to have some issues because the part that's greater than 237 goes to the right of 243. So what ends up happening in this problem is the only part that actually counts is what's in between. And in this case, what's including those numbers because it's greater than or equal to. So we want to do the in-between part when it's going in opposite directions like that. We write it like this. We take our smallest number, 237, less than or equal to x. This is a sandwich inequality, less than or equal to 243. So that's actually technically the solution set to this inequalities. Any value between 237 and 243, including those 2 values. So did it work? Is this actually the correct system or solution set for this inequality? What we could do is we could test some points to make sure that this works. Let's say I wanted to throw in 237 to the original inequality. Does that give me a solution that meets the requirements for this inequality? And the answer here is yes, because 237 minus 240 is -3. And the absolute value of -3 is 3, which is less than or equal to 3. So that actually works. But what about some of the other numbers? Maybe 239? Would that work? Let's try it out. That totally works, because if I throw in 239 into the absolute value inequality, I'm going to get -1. But when I absolute value -1, I get 1, which is less than or equal to 3. So what about all the other stuff to the left and right? Let's take a point way out here, like 245, okay? Will that work? Plug that in and see what you get. Unfortunately, that gives us an absolute value of 5, which is 5, which is not greater than or not less than or equal to 3. So that's not going to be a solution. So that's not going to work. And similarly, anything below 237, 234, that's going to be too small, because when you plug that in, you're going to get an absolute value of a number that is not less than or equal to 3. So the only numbers that work are 237, 238, 239, 40, 41, 42, 43. All of these numbers here that are between those 2 numbers inclusive. Now, look at it from a graphing point of view. When I throw that inequality, the absolute value equation, y equals absolute value of x minus 240 and y equals 3, and I find points of intersection, I'm going to get that 237, that's also nice right here where they cross, and I'm going to get 240, was it 243? And it says mark on the graph y equals x, absolute value of x minus 240, where the inequality, excuse me, the absolute value is less than or equal to 3. Well, here's 3, right? This is 3. So anywhere it's less than or equal to 3 will be somewhere in this part below. Oops, let me get this fixed here. Somewhere in that part where it's below the line, right? Less than or equal to 3 would be here. So if you look where I'm shading, it's all the values in the inequality that are between 237 and 243. So identify the input values that make that a true statement. Well, you would basically say 237, 238, 239, kind of how we did it on the number line, all the way until you hit 243. So any of those, including decimals. So 238.5 would be considered an answer in this graphically and algebraically. Okay, go ahead and go to activity 4. We'll wrap this last activity up in the lesson, and then we'll do a debrief. We just want you to make sure that you're thinking about what this graph looks like. You're going to have to use Desmos to help you do this yourself. So just look at the picture that's associated with what we see here. We have the absolute value of x plus 2. That's this V-shaped graph here. And we have y equals 5. And you can see they do cross at a couple points. And we want to use that graph to think about what you notice between A, B, and C for the equation inequalities less than and the inequality greater than, and what you wonder. Just pause it, see if you think about that, and then we'll start approaching it from a graphing point of view. Okay, so first of all, I hope that you notice that basically each equation or inequality is using this y equals 5 on the right side of it. And we can solve equations and inequalities graphically by separating them out into a system of equations. So hopefully you figured out a couple points where they intersect, so we have some boundaries. I'm noticing that it crosses here. It looks like negative, let's see, 2, 4, 6, maybe negative 7. And then over here, I'm looking at it crossing at 3. So those should be numbers that work. If I plug in negative 7 plus 2, I'm going to get negative 5. And if I absolute value that, I'm going to get 5. And if I plug in 3 plus 2, I'm going to get 5. And absolute value of 5 is also 5. So 3 and negative 7 seem to be the right answers to the equation. So when we're doing it like this one, we don't have to do any inequality statements. We just say x equals 3, x equals negative 7. Now, for the inequality less than 5, we want to go below 5. So where is it below 5? Well, in this case here, it's going to be where it's between those two numbers, right? That's going to be less than, because it's underneath, okay, below. So I'm going to just make a little below. And the way we write that inequality is we take the smaller of the two numbers. So think about a number line, negative 7. We say less than x, less than the higher of the numbers. So when it's less than, when it's below, it's between, okay, between. Now notice I didn't put less than or equal to. I said less than. So what this is end up going to look like here, if I'm looking at it from an inequality perspective, is these are going to end up being open circles because it doesn't really include the points. So I don't want to plug in negative 7 here because I'm going to get 5, and I want it to be less than 5. So it has to be numbers like negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, but not 3. So it has to be between those two numbers. Now, look at the last one. You may notice that the solution where it's greater than 5 is where it's above, okay? I want it to be above that line. So they're not going to be sandwiched between -8 and or -7 and 3 like the one on part B. They're going to be above it. So if you think about that number line again, always go back to that number line. Think about -7 and 3. Now, I don't want to shade between here because I'm talking about this part right here. So on the number line, it's going to look like that. Everything to the left of -7. Over here, I want to shade what's above 3, so I'm going to shade everything to the right of 3. Now, those are two separate inequalities. This one is going to look like x is less than -7, and this one's going to look like x is greater than 3. And because they're going in different directions, we're going to throw the word or between those two. So this is going to be x is less than -7 or x is greater than 3. So you can look at question 2 and you can kind of make your own conclusion about how the solutions to the equation is related to the each other. But basically, you know, your answer here is just x equals 7, -7, x equals 3. You know, when it's an equation, it's just equals. When it's less than, it's going to be that sandwich. So -7 is less than x, less than 3. And when it's greater than, then it's going to be going in opposite directions, like you see here on this graph. All right, go ahead and try question 3. We have 3 different inequalities to solve using graph, and I'm going to have you use Desmos to attempt those and get your solutions. So this is going to be found on page 73, and what I want you guys to do is utilize Desmos and the 2 separate system of equations to get your points of intersection to help solve this. So this is, I'll just kind of model them for you. And this problem here for part A, you're going to want to type y equals 2, absolute value of x minus 4. And in a separate line, do just y equals 6. What we're going to look for are points of intersection. So if you zoom in a little bit, you'll see that they cross in 2 spots, x equals 1 and x equals 7. Now, when we're writing our solution, you got to pay attention to the sign. We want to go below, less than or equal to 6. So we have to write that using the inequality where they're going between. And it's going to look like this. When it's going to be less than or equal to, we want it to be below. Now, here's a little trick for you guys. You can actually type the entire inequality. This only works for inequalities for some reason, but you can see how it's shaded between on Desmos. So let that be a little trick to help you kind of navigate where the shading should be. Then you can write it between them. All right, try letter B. When you graph letter B, you're going to notice that they do not cross, okay? So this is really important that utilizing all your tools, especially using Desmos to see, hey, these graphs aren't going to intersect. Doesn't look like I'm going to have a solution to this set of inequalities. And it turns out that is true. So if they don't intersect, they wouldn't have a solution. Now, however, in this case here, you got to be very careful because inequalities can be either no solution or all real numbers. In this case here, they do not have a solution, and I'll show you why. If you actually type the full inequality in, you're not going to see any shading. Now, if I turn that around and I said less than 6, everything ends up getting shaded. So the solution, if it were less than 6, would be all real numbers. But here, there is no solution. And we're going to write that. All right, let's move on to number 3. Graphing number 3 gives you some messy answers. So when we look at these answers here, of course, they're gonna give you Desmos. And since this said access Desmos to solve them using graphing, we'll go ahead and report our decimal answers here, even though these can be solved by hand. But it's kind of a messy inequality to solve by hand. So we'll use our numbers. But the question is where do we shade? And notice that this graph is turned upside down. It's a little bit different. So we want to look at where is the absolute value, in this case, less than this 1/3 x minus 10. All right, so let's scrutinize this for a little bit. I want to know where is this inequality less than 1/3 x minus 10. Now, 1/3 x minus 10 is right here. That's your linear equation. So it's going to be less than it when it's on either side of these. Now notice they're not connecting here, right? They're going apart from each other. So if you think about the number line, and let me draw that a little bit better. If I draw two numbers here, negative, 2.276 and 3.677. Now that's actually only going to be true when you shade to the left of that 2.276. This is going this way. And to the right of that 3.677 because it's going that way. So they're not connecting here. So the graph is going to give you two solutions, two inequalities to work with. X is less than 2.276. Notice I said less than because it does not have an equal sign. And then X is greater than 3.677. And then since they're going apart from each other, we would use the word or in our statement. When they're connecting each other, we put the X in the middle, and you have your two less thans with the smaller number on the left and the larger number on the right. Now, look back at the graph for a moment. Make that bigger here. Actually, let me just type this exactly as you see it, so there is no wonder as to why it's shading in those directions. If I were to graph this, I'm going to make this bigger. You're going to see that it's shaded in opposite directions of these 2 points of intersection. Opposite directions. So that's how I want to write my my number line. That's how I want to do those shading on the number line. And that's how I want to write my inequalities. Less than the smaller one, but greater than the larger one. All right, guys, that concludes our activities. Let's just take a real quick debrief here and remind you guys what's in these problems in the practice. The lesson debrief, how many solutions can absolute value equations have? Well, it's going to be 1, 2, or no solutions. We can look at what it looks like on a graph to have those types of solutions, and we can solve them by hand. There is a technique to solve an absolute value equation by hand using the positive and throwing a negative where the absolute value is and distributing and solving that equation. And then just kind of going through in your glossary, you do have on page 74 just some cases to consider. I'm not going to read through all of these, but that is in your student glossary. So now we have a cool down, and I'm not going to go over this cool down because this is really designed to do in class, but go ahead and try this cool down. These are basically some practice problems. And see what you can get, and hopefully your teacher, if they're doing this lesson, can check those with you in class, or we can go from the next day. Guys, thank you for watching this, and you guys are awesome. Hopefully this was a helpful video, and now you should be prepared to try the practice problems, and the practice problems will be on pages 79. And you'll see page 79. Let me just flip through and get those all written down. Page 79 through, I said 79, but I meant 76, 75 through 79. So, all right, guys. Thanks for watching. Take care. Bye.